Hi, everyone. We're back again for round two. So this part, we're going to look at just a quick review to start with, and then we're going to get into skip counting. We're going to look at factors. We're going to look at multiplication and division and how the Cuisenaire rods can help us with all of those components as well. Okay, so let's do a quick review first before we do anything. If I were to start with my orange 10, basically, we know that's a 10 rod by now. We talked about trains. And so we said to make a train, basically what we were looking for is, could they take any of the rods, if I don't put any restrictions on them, and can they build anything that goes on top of my orange, however they want to do it. Maybe I do a row with 2 reds, and then I put a white in, and then I have to find other things that fit. So maybe I use a yellow and so on. Okay, so the train was simply a number of rods that covered a specific rod or a parameter that we gave them completely. No gaps, nothing's hanging over there. It's a perfect fit. So if you're doing this along with me, I want you to do the same thing. You might want to even pause the video at this point and just make sure that you kind of have your rods in color order so you can grab them quickly, because you're going to do over the time here several of the same color over and over and over again. We're going to start with an orange. And again, I'm just going to review with trains with you. I would like you to build me a train that has only got the same color on it. So in other words, when I put something onto my orange, I'll give you an example. I just want one color. And I'm going to use whatever number I need, but I'm only allowed to use one color in that row. So in this case, I have 2 trains. I'll just give you a second to go ahead, or I'm going to build it while you're doing yours. So try not to peek. And I'm going to do some more. When you're doing this too, I learned a trick. The kids can have a pencil or a pen handy, or a piece of cardboard, really thin piece of cardboard, like cardstock, even if it's shred, like for recycle. Because then when they want to move things apart, they just slide that paper down between the rows and they just move the entire set of blocks at the same time, rather than doing it all sort of individually the way I'm doing on the demo right now. I found, believe it or not, my pastry scrubber that you have on the top of the counter that you use when you're doing lots of dough and kneading is perfect. You just drop it down and it moves everything around. Okay, so I've got mine done. I have my orange, I have 2 yellows, I have a row of red, and I have a row of white. And anything else is not going to be a perfect fit. There's no other color really that I can come up with at this point that's going to give me that. So that's kind of the start of our conversation today. When we look at this, I see that this is 10 long. I know it's 10. But here I see 2 yellows. We know that a yellow is 5. 5 plus 5 is 10. I see 2 groups of 5. I see 2 rods of 5. You see how we're starting to move already into when we have that language in multiplication of 2 groups of, 2 rays of. Here's 2 groups of 5. 2 rods of 5 gave me 10. Here I have 1, 2, 3, 4, 5 rods that are red. Each one is 2. So 5 groups of 2 has given me an orange or a 10. Or the last one is I have 10 groups of 1 that show me I can end up with a 10. So initially what we would do is have the students write that on a piece of paper. This is 1 group of 10, just 1 rod of 10. This is 2 groups of 5. This is 5 groups of 2. This is 1 group of 10. So we're just getting them to start in terms of thinking about groups. But really, okay, and we'll fast forward and backwards in between here. What have I created? 2 groups of 5, or 2 times 5. 5 groups of 2, or 5 times 2. 10 groups of 1, or 10 times 1. So how does 10 times 1 differ from 1 times 10? We know that the answer, the product, is the same, But when we ask students to say, how are they different? Now they can see this is 1, 10. These are 10 ones. So again, it gives them the visual for the first time of what their math facts actually look like. So we won't do it in this demo, but here's what I would ask you to do is consider when you're working with math facts for the students, have them build it first. Figure out what are the possibilities for all of the different layers that they have. What are all the groups that they can find just to start off with? And we did it with all of the different base 10 rods, just starting from 10, work down to 9, work down to 8, work down. And obviously there's going to be some that don't have a whole lot, right? When you get to 3, there aren't choices. When you get to 5, there aren't choices. It's going to be very limited, but that's okay for them to see that because then they can start to unpack this. In the language of talking sort of mathematical again, I see that 10 can be divided by 5 2 times. So not only am I building their multiplication facts, I'm also building division understanding. I also see that 10 can be divided into 2 in 5 portions. Okay, and I can physically see that. So I would always model one. I always take one of them and model the whole thing with them. Let's talk about whether it multiplies, what are the groups of? So start in logical order, we're going to do the groups of. If you're ready to go to multiplication, have that conversation, then you're going to do that. And then we have that conversation about, well, how do these groups of relate to division? Division is the opposite of multiplying. I'm going backwards. I also see that 5 is a factor of 10. Remember that by definition, later on, when they're doing factors, a factor divides into a number evenly. There's no remainder. 5 has no remainder. When I use the 5 rods, there's nothing hanging over, there's nothing short. 2 is a factor of 10 because there is nothing at the end, no shortages, no gaps, no holes. And then obviously 1. So again, they see the difference between factors and how those fit into that whole parameter of our math facts. I could talk about multiples. I could say 2 is a multiple, 5 is a multiple that leads to a product of 10, right? So I can talk those language, but it's more important that they build it and that they see it. So I'm going to take mine off and let's do the blue one. So I'll give you a head start. Get your blue one out and find all of the factors, all of your, let's start with the beginning parts then. Let's find all our groups. What are the groups that work for a blue? And don't kid yourself when they're just learning, and you know that when they're learning their math facts, it's important to have that hundreds facts table because in our new curriculum, 10 by 10 mastery for grade 3, 12 by 12 for grade 4. But we don't need to bring that out right away and just show them how to run the numbers in the columns. They should be able to see what it looks like, to unpack it, to be able to come up with some common conversations. So for 9, they're going to try. They're going to try greens, they're going to try yellows, they're going to do, but of course we know what the facts are, but I'm going to start building mine. And again, they're going to let them trial and error, and that's fine. That's the whole point behind Cuisenaire rods, is if I'm not sure, I can take the rod and I can simply just try it out, slide it in, slide it out. Didn't work. Yep, that one fit. Nope, that one doesn't fit. So that is the power of being able to bring the math terminology and conceptual understanding that we want them to have right in front of them with their hands. It's only one tool, right? It is not the only tool. It is one tool. So here I see my facts for 9. So I have one group of 9. I have 3 groups of 3. And I have 9 groups of 1. And I would unpack all of that again. So then the challenge would be, can they come up with all the other ones for all the different ones? And like I said, it's going to look very different as we keep moving through. Okay, I'm going to take this and move from our mat back to our rack. Okay, now let's just remember, for those of you who might have forgotten, the rack has 2 sides to it. I have a center row, and for some students, I just may want to ask them, can you show me 3 groups of 3? Sure. 3 groups of 3. So I need to know that green, light green, is 3. And if I'm not sure, I can check it, right, to make sure that it ends at 3. So when I go through and I do this, I see that 3 groups of 3 is equal to 9. So another way for me to show what that might look like on the other side, I might say to them, is there something else that you could make that would be equal to 9? Right now they have to think, what else could I put on here that would give me 9? And we're not adding, we're just finding groups of. Are there other groups of that we could find? So if I hadn't even done the other side, this could be a starting point. And then you do what we did on the map with the other ones, just finding the arrays. So in this case, they might say, well, yeah, we have a rod, and that rod is a 9, so I know it's going to work. So I'm just going to put it down in here, and yeah, there you go. There's my 1, 9. Okay, is there anything else that you can build? So yeah, I could take all of those whites, right, and fill 9 whites in here. So then they're going to, they play with that, but it sticks in their heads fairly quickly. If they've been doing anything with money up until now, they're going to have those opportunities as well, because they're going to start linking some of the things that they've seen with money and those pieces. Now, when I do the other side, or when I turn it over and I look at the dual track, this is where we're going to get some comparisons happening. So let's do it again. Let's say, can you show me, let's say, can you show me 3 groups of 5? So go grab 3 groups of 5. You know what color to grab. And put it on the top track. It doesn't really matter which track they put it on. I'm not sure if it's 5. You can always double check it. So 3 groups of 5. Okay, so how much is 3 groups of 5? Well, I can see there's my first 5. There's my second 5, 15. Correct. Now, what have I also got here? Skip counting. 5, 10, 5, 10, 15, right? So I can build the skip counting that I want them to see. So we're going to do skip counting at the same time as we're going to talk about the associative property. So my question to them might be, all right, you've shown me that 3 groups of 5 is 15. What do you think would happen if we did 5 groups of 3? Do you think we would still get 15? Most of the time, no, because they're smaller. So we'll check it, okay? So can you show me 5 groups of 3? So again, if I'm not sure, put it on there and check. Light green. So 5 groups of 3. And what do you know? Wow. So 5 groups of 3 is the same as 3 groups of 5. So you might ask them, can you skip, is this skip counting? 3, going by another 3, 6, 9, 12, 15. Yeah, sure is. So you might want to ask them the question, is that going to work every time? Or could you find me one when it doesn't work? So we went 3 groups of 5, and you could write it down, and 5 groups of 3. So what if my question was 2 groups of 6 and 6 groups of 2? Right? So let them go at it, let them check it, and of course it's going to both come out to be 12. So this gives them an opportunity to see that when we change the order of our factors and multiply them, it's not going to change our product, right? 2 times 6 is the same as 6 times 2. The order in which I multiply them is not significant, not unless I throw brackets and everything else into it. So the double track allows us to make comparisons. It might even say, and here's my question. We're going to go to, let's see if I can get them all on the screen here. Yep, we can. So I'm going to take these off, and I'm going to say, here's 24. Maybe we'll go smaller. Let's go 20. So are there things that you can skip count by that get to 20 in more than one way? So is there something that you can skip count by that you could fill in here, so same color, that gets me to 20? But is there also another one that you could fill in? Is there more than 2, right? They could even lay them on the outside of the rod. So again, I'll give you a second to think about what that looks like. If you're skip counting, what are the possible ways I can skip count to get to 20? What are some of the parallels that would show up? Okay, so again, I'll start mine off. I could say, well, I know I can go by fives. So 4 5s, that gave me 20. So now I need to think about something else. What else could I do? Well, I could have 2 10s. Now, what can go on the outsides? Because there's more, you know that. What else can they use here? So I'll give you a second to keep filling yours in, and then I'll go ahead and fill the rest of mine in. So you remember that we don't rush this. This is not got to get all of the factors done in one day. They need a little time to do this and really internalize what it is you're asking them to do. So there is no rush. The slower you go for them to master the concept here, the faster you can go later when you just want to go symbolic paper, pencil. Let them really internalize this thinking first and understand what it is you're asking them to do so that they have a sense of what the word multiple means, so that they have a sense of what it means to have a group of, and that they can actually visualize it if they get stuck. They can actually visualize putting things onto the track if need be. Okay, so I also used the purple ones, which are 4. I also used the 2s, which are red. So I have factors of 2s, 10 of them. I have 4s, 5 of them. So this is another way that we can show multiplication, another way for me to show division. Okay, and that might be a question I ask. Can I take 20? So we'll just reverse it. I'll just slide these out of the way for a minute. Can I take 20 and divide it into 2 equal pieces? Okay, so can I take 20 and divide it into 2 equal pieces? So some students will be able to see that I could skip count by 10s and get to 20. But other students they're gonna trial and error. If they're not really clear on what you're saying, they're gonna try them out. But they're gonna very likely go to the big rods anyway. So they're gonna see if 2 rods fit on here. Yes, I can. So 20 into 2 different rods, or 2 rods, 2 groups, is equal to 10. Each group is 10 units long, 10 centimeters long in this particular case. So this gives us a way for them to see how that understanding comes together. So lots of practice on these. And you would ask them, you know, is it possible to have 3 equal groups in 20? And some of the kids will know that off the top of their heads, but some of them will say, nope, okay, it's not going to be the 10. So it's probably not the 5. So I'll try the brown one. Okay, I'm going to try the 8. And I'll put that one on here. And then no, because I'm going to shoot it over here. So when we ask a student to say why a number is not divisible by another number, this is one way we can show that. 20 is not divisible by 8 because there is a gap of 4. It does not fit evenly. It doesn't give me that closed picture that we had before. So again, quickly, kids can figure this out. It's an easy thing to do, and it's a fun thing for them to do. I recently did a parent night, and we were working on things like this. And they first of all, they love playing with the rods, but my point was also that they really enjoyed the fact that they could see it visually, how this division was happening, and they had a better way to explain it to their kids. All right, now I'm going to get you to build something else. So I'm just going to get my rods out of the way here. I'd like you to get 5 white out. We're going to use lots of groups of 5 right now. So 5 whites. And what I'd like you to do, now I know it's going to be hard to see them on here, but we'll do the best we can, white on white. I want you just to stack them. And I will give you, I'm going to suggest even stop the video while you're building. Once you know what you're going to build, then just pause it for a minute so that you can actually build it. So take 5 whites, and then I want you to do the next color, which is the 2s, so the reds. So I'd like you to get 5 and just line them up. So remember, everything's a centimeter. The ends are all centimeter cubes, and they're squares, sorry, and therefore they're always going to fit end to end. Okay. Okay. So I put together a column of 5s, 5 2s. Now I'd like you to keep going. So the next color would be light green or 3s. So do the 3s, then do the 4s, then do the 5s, then do the 6s. You're going to use lots of rods here, but I really would love you to just work this one through because I want you to see what we're going to do with it. Okay, so pause the video. You keep going. Okay, we're going to do the 3s, and we're going to do the 4s, the 5s. We're going to do the 6s and so on. Okay, I have a completed one. I'll just slide it over while you're working on that. Okay, so I actually did mine just virtually, just so I could screenshot it because I wanted you to be able to see the whole thing. I won't be there to see what you got. So really, it's just a matter of us kind of comparing to make sure we're on the same page. So I just outlined my whites because on the white paper, you wouldn't be able to see them. So there was my 5 whites. There are my 5 reds, my 5 light greens or 3s, my 5 purples or 4s, my 5 5s, 6s, 7s, 8s, and then over on the side here, I have my 9s and my 10s. Okay, so now I want you to go back and have a look at what is it that we did here. So if I count this up, I have 1, 2, 3, 4, 5. So I have 1 row wide by 5 high. I could say that this is 5 groups of 1. Or if I'm at that point, I'm going to say that it's, I'll change it to 1 times 5. Okay, it's 1 wide, 5 high. So if this is 1 wide, 5 high, this one is 2 wide, 5 high. I'm going to write it up here. So 2 on the across the bottom, 5 up the side. What is this one going to be? 3 times 5. 4 times 5. 5 times 5. So what are we doing? Setting this out, first of all, lets them actually see every number with the same height because the height isn't going to change, right? Just the length of the rod changes because it has more units in it. So I see 1 times 5 all the way down to, and I'll just move this over so you can see what I've got, 10 times 5. So again, if I were to just think about what have I actually written in here that has value, this is 5, this is 10, this is 15. So I'm seeing the skip counting by 5s before my eyes in area. It gets bigger as I keep skip counting. So here's what 1 skip count of 5 looks like. Here's 2 skip counts of 5 or 10. Here's 15. Here's 20. Here's 25. Here's 30, 35, 40, and so on. So I'm just going to write my answers on the bottom so that you can see them as well. We're just skip counting by 5s. And I won't go off my screen here. I'll just stop. Stop at 40. Okay, I'm going to change colors. So what if I said, how are the reds and the light greens related to the yellows. In other words, when I look at all of the space that a 5 by 5 covered, how does that fit with the 2 by 5 and the 3 by 5? So you know where I'm going. We're saying that I can have partial products here. So 5 times 5 could have been broken up. 5 is the same as saying 2 plus 3. So I could have said that 25, 5 times 5, is the same as saying 2 groups of 5, or 10, plus 3 groups of 5, or 15. 10 and 15 equal 25? Yes. So this gives us an opportunity then for the students to start thinking in terms of how do some of these work together as a bit of an area as well? How do I break up big numbers that I have to multiply? When you ask me to multiply a number, I can't do it in my head. Do I have to do it always with just a straight ordinary algorithm, or can I think it through so that when I start to get these different smaller pieces, I can see visually how they would have combined to come up with this? And before you would leave all this, I mean, you're going to have these on the table. You might say to them, could you find me another way to write 40? And let them pick which ones they're going to do. What's another way to come up with 40? And they might go 8 of those white ones. We hope they're not going to stick there forever, because ones are always easy to do. But that's not really where we want to go, right? We want them to have more than that as well. Okay, so this is a powerful little one. So I would unpack all of these, but then I would go back next day and review and say, can you show me 3 white ones that are 3 high? Because now you're changing what you're skip counting by, right? You're going to change by the height is going to be your total. So you're skip counting by 3s this time. So again, have them build it. And now write out on the bottom, what did you see? What's the patterns? You're into patterns as well. What are we seeing as a pattern? Okay, is there one of these that could be expressed in one of those? Always just letting them go back and forth until this becomes second nature to them, so that when they do get stuck with a big number, they could diagram something out, but they would probably just go to breaking up one of the lead numbers, the factors, and into something that's reasonable, right? Using a factor tree to kind of come up with what values could I do? And factor trees come up pretty early now. They come up in grade 6 and in a big way. Okay, here's what I'd like you to do. We're going to keep on that vein of multiplication. Can you show me 14 and make it efficient? In other words, the least number of rods that you need. So I need a 10 and I need a 4. Oh, and I forgot to tell you, it's not actually 14 that I would like you to show me. I'd like you to show me 4 times 14. So yes, I could madly grab my pencil and start working it out. Or 4 times 14 means I need 4 of these pictures. So let's build 4 14s. You. Okay, so I'm going to build 4 14s. Okay, so I see 4 14s. And what I'm seeing now, if I've understood what we just did, if I wanted to know what 4 times 14 was, what I have is 4 times 10. I can see it. They're right here. 4 10s. And I added 4 groups of 4. So we would write that down. I won't write it on my mat right now, but 4 times, so I can use this here. Okay, so I'll just use my whiteboard because that'll make it easier. So in here, I'm going to be able to see that I have 4 times 10, or 10 rods. And to that, I'm going to add 4 purple rods, 4 groups of 4. So that means that 40 plus 16 should be the answer to my question, which it is. So the answer is 56. So if we can give them some strategies to start breaking up numbers like this, and I know we do that, but Cuisenaire rods do a great job of showing us those kinds of questions. So give them lots of questions like this. Let them, and just say, you know, let's see how quickly we can get one of those done. Let's see how fast we can go through another one. Okay, I'm going to lay one out for you this time. So I'm going to lay out. Let's do this. Okay. In case you've never guessed, I'm not big on giving kids everything. I don't like giving them all the numbers. I wouldn't write all this out. I want them to do that because then I can formatively assess whether they get it. If I just keep feeding them all the information on what numbers there are, I'm not sure if they know what they're doing. Okay, so here's my question for you. After all that work, and you've given a whole bunch of questions, now I'm going to say, I have something up on the board that I would like you to work out. Can you tell me what multiplication statement is being demonstrated by this? Would you write to come up with this answer? So this is my product, my answer. And what would I come up with for my question? So now we're asking them to think backwards. First of all, what was the individual numbers that we were looking at? Well, we know this is 10. We know this is 10. So 10 and 10 is 20. We know that this is 3. So this one row reflects 23. And I did that 1, 2, 3 times. So the question is, what is 23 times 3? So that would be the question for students to write out. And often I say to them, they say, do you want us to write this down on paper? I said, no, I don't need the paper. Neither do you. I want you to tell me what it is. So 23 times 3 is what you're telling me is the question. How can you prove to me that you're right or wrong? Well, we could add all these up and see if that's what we get. We could do the traditional algorithm and verify it that way. Yeah, all of those are true. So let's do it. So 23 times 3 is the same thing as saying that I have 2 10s in here, right? And then I have this. I'm breaking up my numbers and I'm going to multiply these out, or I can just count them, whichever way you want to go. And I'll tell you straight out, that's what the kids will do. So they'll go 10, 20, 30, 40, 50, 60, 3, 6, 9. So I have 6 times 10, or I have 3 groups of 2 times 10, if you want to do that first. And then I have 3 groups of 3. So I get 69. And that is correct, right? 23 times 3 is 69. So I can take these numbers and expand them out any way I want. I can make bigger numbers if I need to, right? It's not limited just to base 10 blocks. And I'm going to say one more thing to you as far as the base 10 blocks are concerned. If this is your introduction to them, you're not going to want to go where I'm going to suggest right now, but it comes up and it will come up later. So remember when we first started in video 1, a lot of you, we said pick one of every color, put them together. Okay, and we were starting to build that. Everybody remembers that, I hope. So really what we were trying to get to, and I'll show us our picture again, was this, right? We wanted to say, okay, have they kind of mastered that the longest rod is 10 to the smallest rod is 1? Absolutely correct. But right now, they know that, and we can prove it by putting it on a grid that is a 1 centimeter grid. I can measure them. But that doesn't mean that that is the only value that these rods can have. The rods will take whatever value you wish to assign to them. So there comes in some higher order thinking. So if they increment by 1, which I can see, what if I said that the white isn't a 1? What if I said the white was 11? Oh, well, now the red is a 12. The green is a 13. This is a 14. What if I said that the white was a 21, 22, 23, 24? In other words, once I understand the concept of how they work, as a teacher, we can assign different numbers, and now they have to think through. So if this was 11, I can ask them to show me all kinds of different numbers. But now I'm also relying on the fact that they understand that this became 15, right? So one little yellow rod is worth 15. So if I say, can you show me whether 5 is a factor of, of 15 is a factor of 60? I'm checking to see whether any of those rods and multiples would end up being at 60. So that means I have to understand the concept of measurement and value as I move through. So I leave you with that because that's a good place to finish our thinking about where we're at just with multiplying and dividing. They need to know the foundational pieces. They're fantastic for building on those concepts of this is a group of, this is a group of, and then we can go to something times something. And once I've got that and I can build sort of a model, a rectangle of what the answer looks like, the product looks like, then I can go in reverse. Okay, then we can do some of those activities that we saw where we use the area of 1 for partial products to understand what that looks like. These are not the only places that we can do that. There are other manipulatives that we can do this with too, but this is how we could best unpack to this point when we talk about how we might use it for multiplying and dividing. So in part 3, we're going to dive into fractions. So if you thought this becoming an 11 was going to be different, well, let's jump into the world of fractions. You're actually looking at them already right on the screen. All right, thanks everyone. We'll see you in the next video.